Okay, here's the video for pages 18 and 19. So just doing examples of what I kind of showed you with the 5-step problem for predicting solutions. So these are just sample problems for this first one. Okay, it just wants us to list entities initially present in the following mixtures and identify all possible oxidizing and reducing agents. Okay, so lead strip, so that's lead solid. It's placed into a copper 2 sulfate solution. So we have copper 2. We have sulfate, and it says solution, so we have H2O. Okay, then again, we're just looking on our chart here. We find each one, so like lead, Pb right there, that's a reducing agent. Okay, and I kind of get in the habit, I put all my reducing agents on the bottom, oxidizing agents on top, but that's just, it's up to you if you want to do it. So like copper 2 is here, it's an oxidizing agent. SO4 is an oxidizing agent, but only when it's mixed with H2O or with H+, but in this case, for this example, we don't have any H+. It doesn't say acidic solution, so we can't add that H+. And then water is an oxidizing and reducing agent. It can be found on both sides, right there. That's with, here's, no, that's H2O2. There's water, and it's also down here somewhere, right here. And so we have it on both sides, so it can be an oxidizing or reducing agent. Okay, for these questions, that's as far as you need to go. And if you were asked to find like the strongest one, then whichever one's closest to the top would be your strongest oxidizing agent, closest to the bottom would be your strongest reducing agent. Okay, this next question, a gold coin placed in nitric acid solution. So again, the gold solid, okay, it's placed in nitric acid. So we have H plus because it's an acid. NO3 minus is the nitrate. Okay, and then solution, we have it in water. Okay, so once we have what's down in our solution, we just find what they are over here. Yeah, I have them circled for us. And so like gold is a reducing agent. Okay, H plus is an oxidizing agent. H plus and NO3 minus is also an oxidizing agent. So these two together. Okay, and then water is an oxidizing agent. And water is also a reducing agent. And so once it's labeled, just one thing to note here, like water is here also, but because we have no oxygen, we don't use this water. It's not part of our equation. Okay, and then if we were trying to find the strongest one, we just look here. So strongest oxidizing agent, okay, would be our H plus and NO3. And our strongest reducing agent in this case would be water. All right, moving on to the next question. We have potassium dichromate solution, so we have K plus. We have dichromate Cr2O7 2 minus. A solution, so we have water. I'm just going to add that over here. It's added to acidic, so again, as soon as we see acidic, we add that H plus. Iron 2, B2 plus. Nitrate, NO3 minus. Okay, now we look through here, find out whether oxidizing or reducing agents, so K plus. Down here is an oxidizing agent. Cr2O7 plus H plus, these two together are an oxidizing agent. Again, just H plus on its own. Okay, right here is an oxidizing agent. Fe2 plus is a reducing agent and an oxidizing agent. NO3 minus, again with the H plus, we kind of put that up here. They're oxidizing agents. And then water can be both, as we've kind of always said. Okay, and that's what we have. And again, if you're looking for the strongest one, our strongest oxidizing agent would be the Cr2O7 plus H plus. And our strongest reducing agent, it would be our iron 2. Last question here. Potassium permanganate solution is mixed with acidified tin 2 chloride. So we have potassium, we have permanganate, and MnO4, H plus, because it's acidified, tin 2, chloride, Cl minus, and then it's all in the solution, so we have H2O. And we label them oxidizing and reducing agents. So our K plus is an oxidizing agent right down here at the bottom. MnO4 and H plus are an oxidizing agent. SN2 plus can be a reducing agent or an oxidizing agent. So Cl minus is up here. It is a reducing agent, and H2O can be both. And then also with that, water and Cl minus together can be a reducing agent. Right up here. It's a fairly weak reducing agent, but it is one, so we still need to label it. And then if we're finding our strongest ones, for manganate and H plus is way up at the top. Okay, and then for strongest reducing agent, it's going to be our tin 2. Okay, now putting all 5 steps together. Okay, for a couple of examples. So again, we start the same way. We label what we have. So we have zinc metal. Okay, hydrochloric acid. So we have H plus. We have Cl minus. And we have H2O. Now we find each of them on our redox chart. Okay, and label them as oxidizing or reducing agents. So zinc is a reducing agent. Okay, H plus is an oxidizing agent. Cl minus, okay, with H2O is a reducing agent. It's also a reducing agent on its own. And water is both. Then you get used to, like, you'll just know which ones are which as you kind of go through it. Always, it's a good thing to kind of check and make sure you've gotten everything. Okay, but now we label them as strongest oxidizing agent, strongest reducing agent. So our strongest reducing agent is our zinc. So it's right down here. And our strongest oxidizing agent in this case is H plus on its own. Okay, we label a 2-half reaction. So again, our strongest oxidizing agent, we write down the half reaction exactly like we see it here. So we have 2H plus 2 electrons, and that produces H2 gas. Okay, and then our strongest reducing agent, we take its equation and we flip it. So we get zinc solid is going to produce zinc 2 plus 2 electrons. Okay, put them together. Okay, so we got zinc solid. Our electrons are already balanced, so I didn't have to times anything. So 2H plus. That's going to produce H2 gas and zinc 2 plus. Okay, and then to see if it's spontaneous or not, and that's when we're predicting these. That's part of that's the 5th step, is predicting whether it's spontaneous. So we look, our oxidizing agents above our reducing agents, so this is spontaneous. Next question, nitric acid is painted onto a copper sheet to etch a design. So we have nitric acid, so H plus and NO3 minus is our nitric acid. Okay, and it's on a copper sheet, so we have solid copper, and then again acid, since it's aqueous here, we also have a liquid water. Okay, label them as oxidizing and reducing agents. Okay, so we have our hydrogen's an oxidizing agent, our hydrogen with nitrate is an oxidizing agent. Copper is a reducing agent, and water can be both. So our strongest oxidizing agents, the NO3 plus the H plus, it's above our H plus on its own is way down here. So we'll write down its reaction again exactly the way we see it in our data booklet. So we have 2 NO3 minus, right out it again exactly as we see it. Okay, and then we take our copper. Since we have the solid, we're going to flip that reaction. We have copper solid. It's going to produce 2 electrons and copper 2 plus. Okay, balance the electrons. In this case, they're balanced. So I just write it out, my total equation, 2NO, 2 nitrates. That's 4H plus. That is our overall equation. And then again, step 5, predicting the redox, whether it's spontaneous or not, are oxidizing agents above or reducing agents. So this is spontaneous.